Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On August 1st, 2016, NASA's SOHO satellite spotted a comet from the so-called Kreutz family, a collection of comets that scientists believe broke off from a giant comet centuries ago. The Sungrazing comet met its demise on August 3rd and 4th, and subsequent news reports have remarked on a so-called coincidence. The SOHO satellite also captured a coronal mass ejection as the comet approached the Sun. Indeed, dating back decades, astronomers have noted numerous so-called coincidental incidents of CMEs corresponding with an approaching comet. The consensus theory remains that no connection between the two events can exist. But countless recent discoveries in comet science, which affirm the electrical nature of comets, emphasize that such a connection should not be dismissed. Let us go back to June of 1998, when SOHO captured two Sungrazing comets whose destruction was immediately followed by a spectacular CME. A headline story on ScienceDaily.com described the event as follows. In a spectacular coincidence, a coronal mass ejection accompanied by an erupting prominence occurred on the southwest limb of the Sun, within hours after the destruction of the comets. The CME and prominence were probably unrelated to the comets, being instead the product of weeks of intense magnetic activity in that region of the Sun. The author of the above paragraph qualified his assertion with the word probably. However, to this day, the astronomical mainstream allows for no electric force outside the Sun to have any significant influence on the Sun's atmospheric behavior. SOHO scientists make the assertion explicitly in their discussion of Sungrazing comets and CMEs. They write, "A popular misconception is that Sungrazing comets cause solar flares and CMEs. While it is true that we have observed bright comets approach the Sun immediately before CMEs flares, there is absolutely no connection between the two events. The Sungrazer comets, in fact all comets, are completely insignificant in size compared to the Sun." But this statement ignores the question of how the Sun's magnetic fields will respond to the approach of a comparatively tiny but strongly charged object. Comets typically display a bright coma extending for hundreds of thousands of miles around the nucleus. They can also entrain an immense envelope of hydrogen gas. In fact, the ability of larger comets to hold their hydrogen clouds in place against the solar wind is just one indication of the comet's electric charge. In considering the relationship between Sungrazing comets and CMEs, it may be useful to review the remarkable effects, completely unexpected to mainstream scientists, observed from comets on the atmospheres and magnetospheres of planets. Let us look back again to the comet Shoemaker-Levy 9's encounter with Jupiter in 1994. At the time, astronomers predicted that the encounter would be as trivial as pebbles falling into an ocean. However, the energetic effects of the comet fragments were astronomically greater than anything comet scientists had anticipated. As reported by Sky and Telescope, when fragment A hit the giant planet, it threw up a fireball so unexpectedly bright that it seemed to knock the world's astronomical community off its feet. To this day, no one has explained why the Hubble Space Telescope detected a flare-up of fragment G of Shoemaker-Levy while the fragment was some 2.3 million miles away from Jupiter. Then, with the impact of tiny fragment A, Hubble detected unusually energized auroral activity. Radiation belts were disrupted, and unexpectedly bright X-ray emissions occurred. Why would a minuscule impactor provoke an explosion of electron activity on the solar system's largest gas giant? Another mystery arose as well. It happened that the Galileo spacecraft was positioned 150 million miles away from Jupiter at an angle that gave it a ringside seat for arrival of the first fragments of the comet. But the impact of the first fragments would be hidden from Earth behind Jupiter's limb. So it was quite a surprise when our Earth-based observatories actually saw some of the so-called impacts start at the same time Galileo did. That means the explosion actually began well before the first fragments physically hit Jupiter. Mission scientists were stunned. In effect, we are seeing something we didn't think we had any right to see. It seems clear that something was happening high enough to be seen beyond the curve of the planet. Radio astronomers had expected radio emissions from Jupiter at high frequencies to drop because dust from Shoemaker-Levy 9 fragments would absorb electrons from the radiation belts, where the electrons emit synchrotron radiation. Instead, Observers were surprised to find that emissions around 2.3 gigahertz rose by 20 to 30%. Michael Klein of JPL said, "Never in 23 years of Jupiter observations have we seen such a rapid and intense increase in radio emission." Extra electrons were supplied by a source, which is a mystery. Similar extraordinary effects were also witnessed in the comet sighting Spring's close encounter with the planet Mars. In October of 2014, the comet passed within 87,000 miles of the red planet, and scientists with NASA's MAVEN mission were amazed at the effects on Mars's upper atmosphere. MAVEN team member Jared Espy said in a statement, "We think the encounter blew away part of Mars's upper atmosphere, much like a strong solar storm would. The main action took place during the comet's closest approach, but the planet's magnetosphere began to feel some effects as soon as it entered the outer edge of the comet's coma." A statement from the MAVEN team reads, "A Mars comet flyby caused a merging of magnetic fields from the comet and Mars. NASA was in the right place at the right time and was able to study what happens to a planet when a comet comes extremely close. Earlier NASA reports had described the cometary encounter adding a, quote, very strong layer of ions to the ionosphere of Mars. Can a similar electrical exchange occur when the coma of an approaching comet penetrates the insulating double layer of the Sun's plasma sheath? The influence of a comet's electrical field will be far more significant than its trivial mass in relation to the Sun. The same logic astronomers displayed in predicting only trivial effects from Shoemaker-Levy 9's encounter with Jupiter has led to their out-of-hand dismissal of the role of sungrazer comets and CMEs. But the view of comets as electrically inert, sublimating ice balls should have been discarded many years ago in the face of overwhelming falsifying evidence. Scientists today continue to describe comets as one of nature's most enigmatic phenomena. Yet how many of these mysteries can be easily resolved if the comet's electrical nature is finally recognized? For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.